Good morning and welcome back. So in the last lesson we were talking about the slopes of parallel and perpendicular lines. We're going to continue on with that, mostly doing some word problems that are a little bit trickier. Okay, so just to review, we said that if you have two lines that are parallel, their slopes will be the same. Because remember, slope is simply a measure of the steepness and direction of a line. So, if you have two lines that are parallel, you should assume that their slopes will be the same because they have the same steepness and the same direction. Just let me switch up my pen. And then, so, slopes are the same. So what that means is if the slope of this guy is whatever, 5/4, then the slope of this guy is also 5/4. Okay? And we'll use that information in the word problems that we take a look at today. Okay? Now, if we have two lines that rather than being parallel are perpendicular, in other words, they cross, and importantly, they cross at an angle of 90 degrees. That's perpendicular. If you have two lines that are perpendicular, then their slopes are also related, but the relation is different. So in the case of perpendicular lines, slopes are negative reciprocals. And again, as I said yesterday, that's just a fancy math term that means if you know the slope of one, you simply have to flip it over and change the sign, and you get the slope of the other. So, if this line has a slope of 5/4, we flip it, becomes 4/5, and we change the sign. If it was positive, your new line will have a negative slope. And again, that makes sense. You can see this one slopes up to the right, which we know is an indication of a positive slope. This one slopes, down to the left, which we know is an indication of a negative slope. Now, another thing about slopes of perpendicular lines is when you multiply them together, you will always get the same answer. And let's take a quick look at that. So, this is an example or a question that we did yesterday, and I'm just very quickly going to write in all the answers. Now, so we have a whole bunch of slopes here and a whole bunch of slopes of perpendicular lines here. Now look what happens when we multiply the slopes of perpendicular lines. We get 3 times -1 is -3. 1 times 3 is +3, which simplifies to -1. Here we have another one. 2 times -3 is -6. 3 times 2 is +6. And again, -1. Very quickly to finish this up, we get -8 over +8 or -1 and -4 over +4, again, -1. Okay. The only time this doesn't really work, although you could say it works, is if you have a slope of 0, right? A slope of 0 might be something like 0 over 1. That would make the perpendicular line negative 1 over 0, which we know is undefined, right? But still, if you multiply these together, you will get not negative 1. 0 times negative 1 will give me 0. 1 times 0 will give me 0. That simplifies to 0. So again, these horizontal and vertical lines just don't want to play along, okay? So again, remember, horizontal and vertical lines does not apply. Now, we can use this relationship between the slopes of parallel lines versus the slopes of perpendicular lines to answer some fun questions. So, if we just drop down a bit to where we left off yesterday. This question says, the slopes of parallel line segments are given, determine the value of k. Well, what you have to realize then is if you have parallel line segments, their slopes are the same, okay? So that means this line, which has a slope of negative k over 5, and this line, which has a slope of 3 over 2, since they're parallel, they'll be equal, okay? Now, given that they're equal, we can set up a proportion. Remember proportional reasoning from the measurement chapter? We can set up a proportion and cross multiply. So, in order to find the value of k, we simply cross multiply and isolate the variable. So, we're going to cross multiply. Negative k times 2 is negative 2k. 5 times 3 is 15. And then we isolate the variable. We want to get k all alone. That means we have to get rid of the negative 2. So we divide by negative 2. Negative 2 divided by negative 2 gives us 1. We're left with k on the left side and negative 7.5 on the right side. Okay? So our value for k is negative 7.5. Okay? Over here, we do the same thing. Knowing that these two slopes are equal, we can set up a proportion, okay, and cross multiply to isolate k. So we're going to cross multiply again. K times negative 4 is negative 4k. 5 times 14 is 70. Divide through by negative 4 to isolate k. That gives us k on the left. And 70 divided by negative 4 is what? Negative 17.5. Okay? So our value for k is negative 17.5. When we move up and look at slopes of perpendicular line segments, they're not equal, remember. But remember, we discovered a relationship between the slopes of perpendicular lines just 5 short minutes ago. And that was that if we take the slope of one line and the slope of another line that is perpendicular, we know that if we multiply those together, our answer will always be negative 1. Okay? So, we can use that to isolate our variable. So, simplify the left side. 3 times k is 3k. 7 times 15 is 105 equals negative 1. Now it looks a lot simpler, right? We want to isolate k. Let's get rid of this denominator first. So, we'll multiply both sides by 105. And that will give us 3k equals Negative 1 times 105 is just negative 105. And then finally, to isolate k, we simply divide through by 3. 3 divided by 3 leaves us with k. Negative 105 divided by 3 gives us, what does it give us? 35? Yeah, 35. So negative 35. So in this case, k equals negative 35. Okay, we'll do one more really quickly. Again, because these are perpendicular, we don't make them equal to each other, but we know that if we take them and multiply them together, we'll always get the same answer, negative 1. Okay? Simplify the left side and isolate the variable. So, negative 4 times 35 is 140. Negative 140 over 7k equals negative 1. Now, having the denominator, having the variable in the denominator of a fraction can give grief to some students. But there's a really simple way when you have 3 terms in your equation. If you want to get rid of this from the denominator, you can simply swap places with the number that's across. Okay, it's a shortcut, but it works. Okay, so we switch places, and that gives us negative 140 over negative 1 equals 7k. This, of course, will simplify to just 140, right? Negative 140 divided by negative 1 equals 7k. And then to isolate k, we simply divide both sides by 7. And 7 divided by 7 leaves us with 1k. 140 divided by 7 is 20. So the value of k in this particular case is 20. Okay? Let's do some word problems. So, remember the trick with all of these is that relationship between the slopes of parallel and perpendicular lines. So, these problems will always give you some information, but because they're jerks, you'll have to use that information and manipulate it a little bit to get to the point they want you to. So in this particular case, they're saying you have a mystery line. And they're asking, or they're telling you, this mystery line is perpendicular to this line. They're also telling you that this mystery line has the same y-intercept as this line. So they're not being nice and just saying, here's the slope, here's the intercept, plug it in. They're saying, we got this line over here that's perpendicular, and this other line over here with the same y-intercept. Well, let's see what we can extract from this. So it says it has the same y-intercept as this one. Well, take a look. This is in slope-intercept form, right? Y equals mx plus b. So the y-intercept of this line is 5, which would be the ordered pair 0 and 5. Oh, we have a point. Okay? So they're telling you this y-intercept is the same as our mystery line. Good. We have one piece of information. Remember, all you need is the slope and one point, and you can write the equation of a line. Okay, so we're partway there. It says it's perpendicular to this line. Well, now we know if we're talking parallel perpendicular, we're looking for slope. So, can we find the slope of this line? Of course we can. Let's find the slope of this line. Well, right now it's in general form, okay? You want to put it in slope-intercept form because that way you can just look at it and get the slope. So let's put this one in slope-intercept form. That means we're going to isolate y. So we have to take away x, we have to add 8 to get this by itself, cancel, cancel, take away x, add 8 to the other side, and that gives us 4y equals negative x plus 8. We're not done yet. Remember, we have to isolate y. So as a last step, we need to divide everything through by 4, and that will give us y equals negative 1/4 x plus 8/4 is more simply written as 2. Okay? But all we're interested in is this number right here. Okay? Now we know the slope of this line. We also know this line is perpendicular to our mystery line. So, if the slope of this line is negative 1/4, the slope of our mystery line will be the negative reciprocal 4/1, or more simply, just 4. Okay? So, we have the slope, we have a point. They've asked us to write it in slope-intercept form. So, if we have the slope and we have a point, and luckily it's the y-intercept, we can just say, okay, for our mystery line in slope-intercept form, which remember is y equals mx plus b, what we need is the y-intercept, well, look at that, and the slope, again, look at that. And that gives us our final answer, y equals 4x plus 5. That's the answer to the problem. So, you got to pull stuff from one line, pull stuff from another line, plug that stuff in, and then you can finally get your equation. So there's a lot to these problems, okay? They take a while. Let's take a look at this one. It says, write the equation of the line, this time in general form, that's perpendicular to this guy. So remember, as soon as you see that word, it means what you're getting out of this line is the slope. And with the same x-intercept as this line. So we need to get a point from this line, the x-intercept, and we need to get the slope from this line. And then we can go ahead and plug them in. Okay? So this one's going to be even more of a pain than this one. So we want to get the slope from this line. So we'll just say slope. And we want to get the x-intercept from this line. Okay? Let's find the slope first. So let's take our line, and remember we need to, just as we did up here, put it in slope-intercept form. So that means we have to isolate y. So we're going to take away 3x, we're going to add 6 to both sides, cancel, cancel, we're left with 2y equals negative 3x plus 6. We're not done. Isolate y by dividing everything through by 2. That gives us y equals negative 3/2 x plus 3. So the slope of this line is negative 3/2. Since it's perpendicular, that means the slope of our unknown line will be the negative reciprocal. So we flip it and we change the sign. Okay? So the slope of our unknown line we know. So we've got one piece of information. To get the other piece of information, we go to our other line, and this time they're saying it has the same x-intercept. So you'll recall from a few classes ago, we said to find the intercepts, you simply substitute a value of 0 and solve. Okay, so if we want to find the x-intercept, we substitute a value of 0 for y. So this will become 6x minus 3 times 0 equals 18. Isolate x, well, 3 times 0 is 0. That was easy. 6x equals 18. Divide through by 6. and we get x equals 3. That puts our x-intercept at the point 3 across and 0 up along the x-axis. So we have the slope, 2 over 3. We have a point, 3 and 0. Once we have the slope and the point, we can go ahead. When you have a slope and a point other than the y-intercept, sometimes it's easier to use point-slope form. Okay? So we're going to plug this point and this slope into slope point form, and then we'll rearrange it into general form. Okay? So remember, and I'm just going to erase some of this stuff to give us some room. Don't need this, don't need this. So remember, our slope point form is y2 minus y1 equals the slope times x2 minus x1. We've got our slope, plug it in, 2 over 3. We have a value for y, it's 0, so this becomes y minus 0. We have a value for x, it's 3, so this becomes x minus 3. Okay? Simplify things. Simplify the left side, well, that'll just simplify to y. Simplify the right side. That gives us 2/3 x minus 2 times 3 is 6 over 3. Okay? Now, if we want to put this in general form, remember we have to move everything over to the right side, and then we have to deal with these fractions. So let's move this y over here. We take away y from both sides, and that gives us 0 equals 2/3 x minus y. And we'll simplify this. 6 divided by 3 is just 2. Okay? Now, remember, general form has to have a positive coefficient of x. That's positive. That's good. Oh my goodness. You can't see this anymore. So let's move it up here. 0 equals 2/3 x minus y minus 2. Now you can see it. So, as I was saying, the coefficient of x is positive, good, but it's a fraction. Not good. We have to get rid of this denominator. You know how to do that. We multiply everything through by the denominator, in this case 3. That'll give us 3 times 0, 0. 3 times 2, 6 over 3x. 3 times minus 1, minus 3y. 3 times minus 2, minus 6. And finally, this will simplify. 6 divided by 3 will give you 2x minus 3y minus 6. Okay? Believe it or not, after all that work, that's our final answer. Okay? Okay, why don't we try this one? Because this one's a slightly different wording, but you're using the same skills that you've already learned. Okay? So this one says, excuse me, given the points S at -3, -1, R at 7, 5, and T at 2, -5, determine the coordinates of a point V on the y-axis so that SR is parallel to TV. Oh my goodness, a whole bunch of words, but basically what we're after is two lines that are parallel. One of them is labeled SR, whoops, gracious, SR, and one of them TV. Okay? S, why don't we, let me just make this a little bit more accurate. Okay, so we have a line, a point S at -3 and 1, which is about here. And R, which is at about 7 and 5, about here. And we have T, which is at 2, -5, so 2, -5, right around here. And they're saying that V is on the y-axis. So that means V would have to be somewhere around here, right? Because it's on the y-axis. So that would be our other line. And they're saying they have to be parallel, so we know it's going to look something like this. Okay? So let's put our points in. -3, -1 for S. 7, 5 for R, 2, -5 for T, and for V, we know one of the points. Since it's on the y-axis, we know the y-coordinate for this point. Oh, gracious. Sorry, my brain is on Monday. There we go. The y-coordinate for that point is at 0 across and some number y down. Okay? Now, remember what we said about the slopes of parallel lines. We said if you know the slope of one line, you can find the slope of the other line. If it's parallel, they're the same. So, for SR, we can find the slope for SR. So that's your first step. Find the slope of SR. Remember, that's going to be equal to y2 minus y1 over x2 minus x1. Since we have values for both points, we can plug them in. y2 minus y1 will become 5 minus -1. x2 minus x1 will become 7 minus -3. That will give us a slope of 5 minus -1 is 6, 7 minus -3 is 10. More simply, 3 over 5. Okay, so now that we know the slope of SR, we can say that's the same as the slope of VT because they're parallel. Okay, so we know that the slope of VT, we'll say therefore, slope of VT is also equal to 3 over 5. Now, stick with me. We know what the slope is for VT. We know both points for T and one point for V. So let's use the slope formula again. But this time we're going to do it for VT. So slope VT equals y2 minus y1 over x2 minus x1. Again, we know the slope of VT, plug it in. We know one of our y values is -5 and the other one is y. So up here we'll go -5 minus y. That's our unknown. For our x values, we've got both of them. So our x values become 2 and 0. So x2 is 2 minus 0. Now let's simplify this, okay? Because it looks weird now, but the important thing is we only have one variable. We can isolate it, and that will give us a value for our y coordinate over here. So let's do that. So 3 over 5 equals, I'm just going to put this in brackets, negative 5 minus y all over 2, right? 2 minus 0 is 2. Now if you look at this, it's a proportion, right? You have a fraction on one side, a fraction on the other side, and as we did just a few minutes ago, if we want to find a value for y, all we've got to do is cross multiply. So that gives us 3 times 2 is 6. 5 times minus 5 minus y, I'm just going to write that out. Negative 5 minus y. And then we can simplify this by distributing the 5 over both. That'll give us negative 25 minus 5y equals 6. Okay? We're almost done. We want to isolate y, so that means we're going to add 25 to both sides. That will give us negative 5y equals 6 plus 25 is 31. Last step, divide both sides through by negative 5. That leaves you with y on this side. Oh, you can't see that again. Okay, up here. Y on this side, and 31 divided by 5, negative 5, sorry, would be negative 6.2, right? Yes, negative 6.2. Now, does that make sense? Well, let's go back over here. We're saying that this value of y should be negative 6.2. Well, take a look at where this point V is. It makes sense that it's going to cross the y-axis at about negative 6. If you look at these other points, I mean, if we had a grid, it would be a lot more accurate, but that's reasonable. So, we've determined the coordinates of this point V. The coordinates of point V are right here at 0 and negative 6.2. So, this is challenging, okay? It's challenging because there's so many little calculations you have to do. You can kind of get stuck, or if you make a small mistake, you can get the wrong answer. So, it's really important to show your work on these things. This brings us to the end of today's lesson. I know this stuff is kind of confusing. This is probably the hardest stuff for this chapter, okay? Good luck with it. Please remember to attend the online help sessions. See ya.